Algebra 1, we've got Unit 3, Lesson 10, and today we're talking about IQR. Looking at box plots and everything, and the IQR is the box part. Remember that a box plot is divided up into 4 equal sections, each one representing 25% of the data. The box itself has 2 of those sections, so that's 25 and 25%. That's 50% of the data. So the IQR is a way of measuring spread. It's different than standard deviation. Okay, standard deviation is like the primo version. It is the statistical version that like the professionals use when they're like really diving in data and calculating with it. But box plots can give us a quick visual of spread. Here's the thing though, the IQR is going to be something that we see in the next lesson that helps us determine whether a data point that's far away from the center actually is an outlier, or if it's just like a faraway point. So the IQR, that measure of that center spread, that center 50%, if we take that distance and go beyond the entire box plot, and use that 1.5 times that distance once and half itself. Any point beyond that 1.5 of that IQR, it's statistically an actual outlier. If it's like right inside of that, like that distance a little bit, then it's not an outlier. It's just a point that's stretched far away. Okay, so let's dive in. There we go. So I think for tonight's problems, I asked you to do 1 through 6, or maybe 1 through 7. I'm not quite sure. Let's see here. So it says create 2 different data sets, each with 5 numbers or less, with a median of 3. So yeah, this is the drive home, a median of 13. That if we want 13 to be in the middle, then that means that as we create a set of data points here, just put some numbers above that, and put some numbers that are below that. There you go. We need each with 5 exact numbers. There we go. We got that. We could create another one, but we could just have it be like all like 13s. That's fine. All right. This is one of those things where it's like you get to be in control of the data set, and you can create it yourself. Did we miss one? Yeah, no. This is just a summary slide. Oh yeah, there's IQR. It's the distance going here from 3 to 12. Well, that's 9 units. The IQR is the measure of spread in a box plot. Okay, so we got here. These are box plots. The box plots represent the points scored per game for 3 different football teams over the course of a season. There we go. We got team A, B, and C. Which team generally scored the most points? Which team scored the most points in a single game? Okay. Most points in a single game. That's going to be easy because each one of these dots is the points that they scored in a game. So we want the dot that is the highest, and that would be this one. So team A had a game that was the highest. When we look at like which one generally scored more, now what we're looking at is we're looking for that, like looking at the IQR, the measure of the center, and where that is. I would generally say the team C generally scored, more points per game than the other 2. The other way is to look at the median, that middle line. Their median is higher than all the others. All right, let's move on. Same thing. Which team was the most consistent? The most consistent team is going to be the one whose points are closer to the center. So how do we measure that? It's the IQR. It's the box. So we look here, and we look at this box. That's clearly bigger. That box section from end to end is clearly bigger than the other 2. These 2 are pretty close. So what I need to do we have the movable line? No, we don't have the movable line. But all right, so let's see. 14. This looks like it's like 13 right here. So 13 to 20, not to like 24. Okay, so if it was 13 to 23, that'd be 10. So this looks like, but it's to 24. So it looks like it's 11 units wide. This one looks like it starts at 23, and it goes to 35. Well, if it was 23 to 33, that would be 10, but it's to 35, so this looks like it's 12. Right there, we can see that numerically this one has the smaller IQR, the smaller section for that for the box. 50% of the data is grouped in a slightly smaller area. So team B would be the most consistent. Why? We just did it. Okay, and all right, so Mariana used a fitness app to track how many miles she walked each day in July and August. Okay, here's a box plot of her data. Which month has a smaller IQR? Well, right there, August, you can see it, the box part. Your eyes go to the box, we can see. Oh, and it does give us a movable line. We could see right there. They both start at 3, but this one ends at 5. The other one ends at 5.5. Let's move on. Here's a data set. If you added 24 to it, how would the IQR change? Okay, so since 24 is outside of where the center of this would be, it definitely increased the IQR. All right, if they said something like, hey, we're going to add a number like 4 to this, well, 4 is within the lowest to the highest, the range. It's not going to really pull things too far from the center. It might increase it a little, because looking at this, it looks like the center might be somewhere around 6 or 7 or so. So, all right, let's move on to number 7. Here's a different data set, 3, 6, 7, 23. My God, this lesson is delivering. Okay, determine a number you could add to make an IQR of 15. Okay, so right here, we could just copy this. And we could paste this here, and it would say use IQR. Use that command. Is that a command of this? Will that deliver us? Okay, so that's not going to give us that. Let's go to the functions. Let's see what we got. Let's get rid of my face. Okay, let's go to the functions here and see. Do we have? So we want statistics, quartiles. All right, so. Stats generally is a good one, so let's get rid of that, and let's put these numbers in here and see, will it give us the stats for those? Well, it's not, it doesn't like that. So I think what it wants is it wants me to do like a list equals, and then put the points in here, and then on the next line do stats of the list L. Okay, there we go. We got minimum, maximum, Q1, Q3. Okay, so how about if I were to do IQR? Is that a command? IQR of that. Oh, let's see. No, it doesn't like that. So, all right, let's get rid of that. I was just wondering if we had a command for that. Let's see. Again, we're just messing with the other functions here: mean, median, min, max, quartile. Wonder what that does. Quartile L. Will that give me? No. Okay, it's not doing that. Let's see. Just looking here. Just stats, very. No. Spearman diagram. Oh yeah, stats count total. All right. So, I mean, we could do a box plot. We could always do a box plot of L. There we go. And we want this to have. We want it to have determine a number that you could add to make an IQR of 15. So we want that box to be stretched 15 units. So here's the nice thing is that we can just kind of like mess around with this. What if we made this 40? All right, if we did 40, that would definitely stretch it. Oh my God, that's hard to see. Stretch it. That seems to be too high. So let's do 30. Okay, still too high. 10. Let's do 25. Okay, so here now we're getting closer. So it looks like we're at 24, and this stretches down here. So I'm still not liking it. So when we're at 23 right there, that was at 15. All right. So that was at 15. Could I stretch this so that the box was down at 0? That would give me a target. So what if I added 0? Not enough. What if I added -5? Ooh, what if I added -2? -2. No, -3. -3 would do it. Okay, so this is one way. This is the way that I'm choosing to solve this problem, is that I can keep this upper part locked in, but I can move the lower part by adding in lower and lower numbers. So if you didn't do this, you could do it the other way. Leave the lower part of the box plot locked in at where it was right here at 4, and keep adding higher and higher numbers until we get 15 numbers higher than that, until it's up at 19. So, what was it? -3 is what we got? My gosh. Okay, hey folks, that's it. Take care. Hope this made sense. Bye, folks.